in the previous class, we have discussed about this first order detection operator and second order derivative operators. And in the today's class, I will try to discuss about this edge linking algorithms, and in the next class, I will try to discuss about principle of thresholding. So yeah, so till now we have discussed about edge detection algorithms. So by using those edge detection algorithms, I will try to find out the edge points. So in the today's class, I will discuss how those edge points will be linked with each other. So in case of this edge detection, some noise may also be treated as edge. So to remove to get the perfect edges, I will try to use this edge linking algorithms. Until now, we are discussing in the many classes. In the previous classes, we are discussing about what is we have to take some threshold value. So how to take the threshold values will be discussed in this principle of thresholding. So that completes my total unit of this one, unit 3, that is image segmentation. So in the today's class, I will discuss about this edge linking algorithms. So use it to group the edge points that are detected using edge detection algorithms. So in the previous class, we have discussed about this edge detection algorithms. We have different edge detection algorithms based on the derivations and based on the different operators like first order derivative operators and second order derivative operators and Gaussian based. We have discussed many of the edge detection algorithms. By using those edge detection algorithms, we will try to find out the edge points. But how those edge points, one edge point will be linked with another edge point, so that it should be forming the correct edge can be done by using this edge linking process, edge linking or edge thinning. So this is also one of the process, or we have already discussed about the edge detection stages. In those stages, we are having one of the stage like edge thinning and linking that can be done in this one. So there are two important algorithms or methods which are used to link the edges. So one is your local processing, that is called local edge linker, and another is your global edge linker, which is also called as Hough transform. This is one of the most commonly used technique, which is used to detect the shapes like lines and circles. In case of this one, if you go through the go through this one also, you can find out lot of papers on the Hough transforms. So next one, this is your the first technique is your local edge linker, in which here we are using the we are getting the points. Those are called edge points. We will link those points or group those points based on some similarity criteria. We will follow some similarity criteria based on that predefined criteria. I can, if that edge, whatever the we are having one edge point and we have another edge point. We have this. We are getting lot of edge points by using the edge detection algorithms. After getting these edge points, I want to link this edge point with another edge. So if I want to link that particular edge with another edge point, then I have to follow some criteria. I will mention some predefined criteria. So based on that predefined criteria only, I can group that particular edge. That is called local edge linking. So what is the steps that we follow in the local edge linker is, first we will detect the edge points here, not edges. We will detect the edge points using this edge detection algorithm, and after this one, analyze characteristics of the edge points with neighborhood. So after getting those edge points, I will check one edge point with the neighborhood edge point, and I will group that into the edge if the predefined criteria or similarity is met. What is that predefined criteria? We will see now. So let we are having x comma y is the one edge point, and we are having one more edge point called x0 y0, which is a neighborhood point. So then we can group that those two edge points by using this. This is the predefined criteria that we are following in the local edge linking process, in which we will try to find out the magnitude of the first edge point and the magnitude of the second edge point. We have already discussed about how to find out the magnitude. So what is magnitude? So we are having we need to find out the derivation or magnitude, gradient derivatives with respect to x and y. So this is nothing but dou f by dou x and dou f by dou y. After finding out this derivation with respect to x, so why we are finding derivation means, if there is a change in the intensity values, then I can say it is that may be there in the edge point. So based on that one, I will try to find out the edges based on this derivation. So after this one, I will find out the magnitude by using this formula, that is gx square plus gy square root, and I will find out the direction. So what is the formula for finding out the direction is, that is tan inverse of gy by gx. So once this magnitude and direction is found, so based on that only we will try to find out the edge points, whether if it is following some predefined criteria, then I can say it is a edge point, that is in the edge detection. But in case of this edge linking, I will try to find out the magnitude of this first edge point and magnitude of second edge point by using this formula. After finding out those magnitudes, I will try to subtract those two magnitudes, and if both are less than or equal to some predefined value, this is called threshold value. This is magnitude threshold value. Based on this threshold value, if this criteria is met, I can say I can group those two edges. In the same manner, direction of the first edge point I will find out by using this formula, and the direction of the second neighborhood edge point by using this formula, and I will subtract both the points. And if it is less than or equal to some threshold value, this is called angle threshold. So we are having two threshold values. So how to find out these threshold values, we will see in the next class, that is principle of thresholding. So we are always telling about whenever we are always we are trying to compare that with the threshold value. But what is the threshold value, we will see in the next class. So here, but what is the process that is going to follow in the local edge linking process or local processing is nothing but, first whatever the edge points are there, we will find out in the edge detection algorithm. First point will be compared, second point we will consider two points, neighborhood points, and after this one, first edge point we will find out the magnitude, and the second edge point is also we will try to find out the magnitude. If we subtract those two magnitudes, if that value is less than or equal to this threshold value, magnitude threshold value, then I can say I can group that particular edge. And also I will take one more, I will consider one more thing, like criteria. This is the predefined criteria. Direction I will find out for this edge point, and direction I will try to find out for this edge point. And if I subtract those directions, then if that directions is less than or equal to some angle threshold value, some 45 degrees, or we will take that threshold value. This threshold value may be some intensity value like 125, some value I will take 5 or 10 something. If both those criteria is met, if then I can group that particular edges, I can link that particular points. In the same manner, for this I will try to find out the same criteria. If that is meeting, if that is satisfying, then I will group. If this is not satisfying, then I won't group that with the particular point, so I won't consider this as the edge point. So like this I will try to follow this edge linking process in the local edge linker. In the same manner, I will have one more, that is called local edge linking process, and we are having one more edge linking process called global edge linking process, which is also called as Hough transform. So what is this Hough transform? So Hough transform is this is also global edge linking, so which is also trying to find out the edges only. So but it will follow some special procedure, like Hough transform is a feature extraction method. It is mostly used in the feature extraction, like whenever we are having lot of images, we will try to find out the features. So what is features? Nothing but those are the uh, uh, critical points, so which are unique points. So for that particular image I will try to find out the features. So most of the feature extraction, because in case of this image processing, we will have one of the whenever we are dealing with any image processing problem, one of the important step is feature extraction. I will try to get the features, like if I are taking the facial, if I want to detect the facial recognition is my image processing application, then what are the features, like he may having some unique eyes or something from the face, I will try to get the unique features. So in the same manner, most of the Hough transform is mainly used to get these features. So in feature extraction method, for detecting simple shapes such as circles, lines within the image, whenever in the image if I want to find out the unique lines, so based on particular within the image, I will try to find out the unique lines, so that those will be compared with another image, like that. So whenever I want to find out the lines and shapes, circles in case of the image, line shapes and circle images, then I will go for this Hough transform. But basically Hough transform is used for linking the edges only. So simple shape in is one that can be represented by only a few parameters. So because why I am taking these lines and circles, because it is easy to find out the lines and circles from the image. Like for example, line can be represented by two parameters only. I can have, whenever I am having line, always that line is nothing but we are having the formula y equal to mx plus c. So always these points are there, and I will try to find out this slope and intercept values. In the same manner, circle, why I can easily find out the circles within the images, because each is also having only three coordinates. Like we are finding out the xy, what is the for a circle I will try to find out the what is the central coordinate value and what is the radius, so that I can easily find out the circle. So I will, for the circle I can consider only three arguments. For a line I will take only two coordinates. So not coordinates, I will try to take this these two coordinates, I will try to find out the coordinates like slope and intercept values. So Hough transform does an excellent job in finding such shapes within the image, so lines and circles. So the main advantage of using the Hough transform is that it is insensitive to occlusion. And next, so yeah, so in case if you want to know about this global edge linking using Hough transforms, you have to follow some, you have to know some terms like what is image space and what is parameter space. So when we know that a line correspond to a point in the parameter space, whenever we are having a image space, this is your normal I will try to represent that particular image in the xy coordinates. Then what is the line is nothing but you will try to draw this line, particular line. Then what is the formula for line equation is y equal to mx plus c. So this is your line. But if you represent the same line in the parameter space, then whatever the line that is there, that will be converted into a single point. So I will try to find out this m and c slope values. So whenever we consider this image space, whatever the line is there, for this line I may have many points will be there within the line. So if you convert this particular image space into parameter space, why we are converting everything we will discuss in detail. So in case of this Hough transforms, it is we have to, what is the main motto of Hough transform is you we will try to find out the lines and circles within the image. Those shapes I will try to find out, that I will try to use within the edge linking process. The same thing here I will try to use whatever the image space is there. Whenever we have a line which is there in the image space, for this line I will convert into the point in case of this uh, uh, yeah, parameter space. So what is this parameter space is means this is your xy coordinates are there, this is your image space. But I will consider only this I will consider this x and y, I won't consider this x and y values. Take I will convert this x and y coordinates into the m and c, that is nothing but intercept and slope space. Like this is your AB plane, you can call it as AB plane or MC plane, anything. So so because a line has fixed slope and intercept, always this line is having fixed slope and fixed intercept, because always these points will be changing only whenever we are having this line. Whenever we are having this line, in case of this one I have some point like this may be 1 and this may be 1 2 something like this one. Here we are having 1 2 3 4 5 6 7 like this. Then this point is 1 1 and this point is 2 2 1.5 something like 3 2 3 1.75 or 4 2 like this. It may be line may be say we are having different points. In case of this one we are having different points, like this is 1 1 and this is your if you are taking all these points, line is nothing but we are having a infinite number of points only. And after this one this is your 1.5 comma something like this. All these points, if I, because all are having the same fixed intercept value only these points will be changing, but this slope. So when I represent this image space in the parameter space, like xy plane is converted into this AB plane, then for this one I am for, even if it is a line which is having infinite number of points also, whenever I consider this AB plane I will take only one value, one unique point, that is your slope and intercept value. So in the same manner, so this is why this I am using here is because by changing the space we reduced the line consisting of many points. but but if I am using this AB plane I can use only single point. The entire line that is there in the image space, that can be easily represented by using a simple point in case of this parameter space. So because of that one I can reduce the storage and further computation. So in the same manner, a point corresponds to a line in the parameter space. In the same manner, if you reverse that one, if you have this image space, in case of this image space I have one point. So for this point, for the same point, if I want to represent in the parameter space, like this is your AB plane or MC plane, you in some textbooks it may be MC plane or in some textbooks it may be AB plane. So when I have one single point that is there in the image space, for this single point I can have many number of lines. So I can have, for this single point I can go through for this point I can go through many number of lines in the single point, so that whatever the point correspond to a line in the parameter space. So for this for this line I will get one point, because in the previous topic only we have seen, like for a line in the image space I can have point in the parameter space. So that's this can be in reverse also, the same thing. for a point in the image space, we can have many number of infinite lines that can be follow that can flow from this point, so that for this line I have one point, and for this line I have another point. So like this I can get one line in case of this parameter space. So because there can be infinite lines that can pass through the point, and for each line we have the point in the parameter space. So what is this Hough transform is, let's combine these two, in which suppose there are 2 points, we are having 2 points, we are having we can have any number of points in the line, but we are considering only 2 points. So can you find out where the line joining these 2 points match the parameter space? So for this point I will try to find out the line, and for this point also I will try to find out the point, and wherever we are getting this intersection, that is your intercept value, that is nothing but we will try to get this values, mc values. So obviously this would be equivalent to the intersection point. So we will find out that intersection point. Then if that line whatever the points that are there in the edge points, if those edge point is passing through that particular intercept of line, then I can say that point is there in the edge, otherwise I won't consider. We will take one example, then you will understand. So this is what Hough transform does, each edge point. So for each edge point, so whatever the edge points that we are getting in the edge detection algorithm, for each edge point we will try to draw the lines in the parameter space. I will try to draw lines, because for each point that is there in the image space will be line in the parameter space. For each point that is there in the parameter space, there is a line in the image space, that is vice versa. And for each edge point I will try to draw the lines. One after drawing the lines, wherever we are getting the intersection, that that intersection point will give the slope and intercept values of the line. So yeah, we will try to take one example, then you will understand how I can do this edge linking by using this Hough transform. So Hough transform is mainly used for edge linking. So what is edge linking? So we will discuss what is edge linking. So we are considering one image, like this is a cubical image. By applying different mask or filter that we discussed, like first order derivative operators or second order derivative operators, we will try to find out the edges, edge points. We will try to find out the edge points. But due to this noise in the image and changes in the image, we can get some breaks in the edge detection. Like if you observe in the previous also, we some points we cannot find out the edges, like these are the edge points we are getting, but in some points I may get the breaks. Because of that, there is no process of the I don't know whether it is edge or not. How to break, how to combine this one, that for that one only I will try to use this edge linking process. So in between also I may have edge points, but I don't know how to link those edges, whether I can combine or not. So for this one only I will try to apply this edge linking process. Like we are getting some edges, after getting these edge points I will try to draw in the image space, like this is your first edge point 1 5. So I will try to like I am having this 1 5 over here, and after this one the second edge point is like 3 1. So for example, if I am considering these are the two edge points that we are getting after applying the edge detection algorithms, so 3 1. So I am getting this through 2 only, but I don't know how to combine this. Whether how can I combine? So in normal case, I can easily combine. I can easily draw the line. I can easily draw the line, but it is very difficult for the machine to draw this line and to find out these edges. So for this only, I will try to apply this Hough transform or global edge linking, where it is very difficult for the machine to form the equation line y equal to mx plus c. So I can even if I am having this two edge point also, if there is a break in this particular thing, I can easily draw the line. But for the machine, it is very difficult to draw this line. So for that one, I have to use this process. So what is that process over here is, whenever we are having this line equation is y equal to mx plus c. So this is your xy plane. This is called xy plane, or which is also called as image space. For this plane, I have to convert this particular xy plane into AB plane. So how can I convert this xy plane into AB plane is nothing but y equal to mx plus c. M I will consider as A, and C I will consider it as B. So that is nothing but y equal to ax plus b. And after this one, I will try to write like this one, b equal to y minus ax. That is nothing but b equal to minus ax plus y. So what I am doing over here is, in case of the previous thing, xy points. So xy points I will take it as fixed values, and I will try to find out the slope values, so that we will see. Now xy plane is converted into AB plane. So whatever we are having xy plane, that is nothing but in case of this edge points, whenever we consider these edge points, that is in the xy plane. But in case of this Hough transforms, first step is to convert this xy plane into AB plane. After converting this into AB plane, so how what is the formula? That is nothing but y equal to mx plus c is there, but I will try to convert this into AB plane. So y equal to nothing but ax plus b. So now b is nothing but minus ax plus y. So this is the AB plane equation. In case of this AB plane equation, whatever the edge points are there, for each edge point I will try to substitute in this particular thing. And once you substitute that one, I will try to draw after substitute in that particular equation, I will try to draw the lines, and wherever we are getting that intersect point, I will get those slope values, a comma b values. And after getting those slope values, I will try to substitute in the original image, like AB values I will try to substitute in this particular equation, so that I will find out whether those points are there in the edges or not. So I think let we take one example, then you will understand. So like after after applying this edge detection algorithm, I am getting these points. So these are the edge points. I am getting total 5 edge points. Now I will try to find out which are the edge points that are there in the final edge, and which are the edge points that are not there in the final edge. So for that one only I will try to use this Hough transform. So in case of this Hough transform, first we will have this equation. For this equation I will try to convert into the AB plane. So for this one, what is the normal equation is y equal to mx plus y, but I will try mx plus c, but I will try to take m as a, and I will you can have MC plane also, no problem. But for simplicity, for easy to understand, I'm taking this m as a and c as b. And after this one, I will try to substitute. I will try to convert this equation into the AB plane equation. That is nothing but this is your a and this is your b. So how to convert is nothing but, so b equal to this is just minus ax plus y you are getting. So this is the final equation. Now I will try to take these points like A14. I will after first step within the Hough transform is whatever the xy plane is there, that you will convert into AB plane. After converting that one, I will take all the edge points like A14 I will take, and after taking this one I will substitute in this one. So what is the equation that we are getting is b equal to x is 1, so minus a plus 4 I will get this one. And whenever I am having the second edge point is b23, so for this one if I apply, that is nothing but b equals to minus 2a plus 3, because this is your x and this is your y. And next c is nothing but 3 1, so now I will try to convert b equal to minus 3a plus 1. And after this one, d is nothing but 4 1, and I will try to take this b value as minus 4a plus 1. And after this one I will take e is nothing but 5 minus 5 comma 0. Now this is converted into minus 5a. So these are the total 5 equations that we are getting, 5 line equations. So whatever the edge point is there, each edge point will be converted into line in case of this parameter space. Yeah, in case of this image space we are having edge points, those will be converted into lines in case of this parameter space. So after this one we are having, these are the 5 equations. Nothing but the first equation is b equal to minus a plus 4. So after substituting those points, I am getting these equations. For the first point I am getting this minus a plus 4, and the second one minus 2a plus 3, and for the third point I am getting this minus 3a plus 1, and for the fourth point I am getting the this equation, that is minus 4a plus 1, and for the fifth point I am getting this minus 5a. So for each edge point I will try to convert that into the parameter space. After converting into the parameter space, I am getting these 5 equations. Now we have already seen for each edge point that is there in the image space, like 1 4 2 3, 1 4, yeah, a 1 comma 4, and b 2 3, and c is your 3 1, and d is 4 1, and e is your 5 0. So we are having all these points. For each point I am having a always there is a point which is there in the image space that will be converted into line in case of this parameter space. So how I will do the just first of all I will try to convert that into the AB plane. So whatever we are having this y equal to mx plus c, I will this is the normal xy plane equation that I will try to convert into the AB plane. So for this one y equal to ax plus b, and after this one b equal to minus ax plus y. So once we are having this xy point, so if I substitute that one, I am getting 5 equations. Now I will try to, for each point I will try to represent in the this one in this format like equations, how I will get these equations. So I'm taking this as a and this is b, and after taking this one I will try to take the first equation, and the first equation I will try to find out the so I will try to take this as 1 and this as 2 and this is 3 4 5 6. And after this one here I am having 1 2 3 4 5, and here I am having 1 minus 1 minus 2 minus 3 and minus 1 minus 2 minus 3. And after taking this particular values I will try to represent these in the diagram format like so for this first one a minus a plus 4. So I already first point is 1 4. So for this point I have to for each point that is there in the image space that will be converted into line in case of parameter space. How it will be converted? So first I will take a value as 0. So if I take a value as 0, then b will be getting as 4. I will get whenever I take this a value as 0, then I will get b as 4. Whenever I take a as 1, then I will get b as 4 minus 1 is 3. I will get this point, and after I will get this point. Next whenever a value is 2, then b value is also 2 because 4 minus 2, and a value is 3, then I will get b value as 1, and a value is 4, I will take 4 minus 4, then I will get b value as 0, and a value if I am taking it as minus 1, then I am getting this b value as 5, b value as 5, because whenever I am having a equal to minus 1, then minus 1 of minus 1 is plus 1, so 4 plus 1 is 5. I am getting this equation. So for each point I am getting this kind of equation for the first one. This is nothing but b equal to minus a plus 4. Next minus 2a plus 3. Whenever I am draw this one, a value 0 means b value 3. So whenever I am a value 0 means b value is 3, and a value 1 is nothing but b value is 1, because a value is 1 means b 3 minus 2, that is 1, and a value 2 means minus 1 I will get. A value 2 means minus 2 into 2, so minus 2 into 2 minus 4 plus 3, that is nothing but minus 1. So a value 2 means b value is minus 1, I will get minus 1, and a value 3 is nothing but I will get minus 3. I will get minus 3, and whenever I am having this a value is 3 means b value minus 3, and a value is minus 1. If I am taking a value as minus 1, then I am getting this minus 1 into minus 2, that is 2 plus 3 5. So whenever a value is minus 1, then I am getting 5. So now I will try to draw this line, this particular second one, that is nothing but this is your b equal to minus 2a plus 3, and for the third one also minus 3a plus 1. So a value is 0. Whenever I am having this a value 0, b value 1. So a value 0 means b value 1 I am getting, and a value is 1 means minus 3 plus 1 minus 2. So a value 1 అయితే b value minus 2 వస్తుంది. Next a value I am getting a value next a value is I am taking it as 2. Whenever I am taking a value is 2, I will get minus 3 into 2 minus 6 plus 1. So minus 6 plus 1 కాబట్టి minus 5 వస్తుంది. Somewhere I will have over here. And whenever a value is minus 1, whenever I am taking a value as minus 1, minus 3 into minus 1. So 3 plus 1 4. So I am getting over here. And next a value is minus 2. If I am taking minus 2, then minus 2 into 2 minus 2 is 4 plus 3 7. So whenever minus 2 is there, then I will get 7. So 7 somewhere over here. So it will be like this. It won't it will be you are getting the equation like this. And after this one, if I am taking this minus 4a plus 1, for this one a value is 0, then we are getting b value as 1 only, and a value is 1 means I will get b value is minus 4 plus 1, so minus 3 I will get, and a value is 2 means minus 4 into 2 is 8, minus 8 plus 1 is minus 7 you are getting somewhere over here, minus 7 somewhere over here, and a value minus 1 this whenever I am taking this a value as minus 1, then minus 4 into minus 1, so 4 plus 1, so I will get 5 only. So the equation of for this particular thing. So a value is 1 means that is minus 4 plus 1 3. So I will be getting, and a value is 0 means b value 1. So I will be getting like this. I will be getting this kind of equation. After next b value equal minus 5a, that is nothing but only except this equation. So after b equal to minus 5a, so a value 0 means b value is 0 only, and a value is 1 means b value is minus 5. I will be having minus 5 over here, minus 4 minus 5, and a value is minus 2 means it is getting minus 10, and a value is minus 1. If I am taking, I am getting 4 over here. So that is nothing but you will be getting this equation. So after drawing these equations, I will get one equation like, except this equation all will be intersect with one point. Intersect with one point. That point we have to find out. That is the motive of this Hough transform. In case of this Hough transform, first whatever the edge points are there, for each point I will try to convert into the AB plane. For each point that is there in the image space, that will be converted into the line in the AB plane. After converting this one, these four lines are intersecting with one point. What is that point? Is minus 1 comma 5. That point is very important. Okay, after drawing the lines, I will try to find out the intersection point. So that intersection point will give the AB values. That is nothing but slope and intercept values I am getting by after applying this one. So what are the final intercept values that we are getting is a equal minus 1 and b equal 5. Once after getting these intercept values, I will try to substitute those values in the final equation. That is nothing but y equal to ax plus b. This is the equation. First equation is y equal to mx plus c. So that whatever the intercept values that we are getting, a comma b values, those I will try to substitute in the final image space equation. This is your image space xy plane equation. In the xy plane, so after applying this one, I am getting the intersection point as minus 1 comma 5, because all the points are flowing through this minus 1 comma 5. After this one, I will get that particular values, a equal minus 1 and b equal 5. At this point, four lines are intersected except this third one, that is nothing but minus 3a plus 1. All the remaining lines are flowing through that particular intersect point. So after this one, I am getting this whichever is flow. If many number of lines are passing through that particular point, that is called intersection point, where we are getting this plane AB values, intercept and values. Once those values are getting, I will substitute here. That is nothing but y equal to minus x plus y. So this is the final equation that we require. That whatever the equation that we are getting. So what are the steps that we followed is, first all these edge points are there. We are getting those edge points, and after getting those edge points, for each edge point I will try to convert this edge point into the these edge points that are there in the xy plane. Those will be converted into the lines in AB plane. After converting these lines, I will try to find out this intersection point, and after this one, getting this intersection point, I will try to substitute in the final equation. This is the final line of equation. Now after getting this minus x plus 5, so after getting this particular equation, I will try to substitute these values, whether which are correct or not. I will try to, whatever the edge points that are there, right, those edge points I will substitute in this particular equation. So first a equal to y. If I am taking this as these are the edge points only we are taking, till now we take this edge point. So I will, after getting this particular line equation, because first these equations will be represented in the parameter space. After this parameter space, I will get the intersection points. After getting those intersection points, I will try to find out the slope and intercept values. After finding out those slope and intercept values, I will try to substitute in the equation. After finding out this equation, now x value is 1, then y value is 4. We are getting correct only. X value is 1 means 5 minus 1 4. So that's why I will try to draw 1 2 3 4 5 and 1 2 3 4 5. Now x value is 1. So y value is I am getting 4, correct only. So this is this point is satisfying that particular equation. So I am getting point over here, that is 1 4. And next b value 2 means x value is 2, then 5 minus 3 2 is 3. So this is also satisfying that particular condition. So 2 3. So this is the point. This is the point that we are getting over here. And next x value is 3 and y value is 1. So x equal to 3. So 5 minus 3 is 2, but we are getting here actually you have to get 3 2. You have to mention 3 2, but it is not satisfied. So 3 1, so I am having 3, I'm 1 3 1, I'm having 3 1, this is 3 1. Next 4 1, so if x value is 4, then y value is 1, I have to get y value as 1. So 5 minus 4 is 1, so I am getting the correct value. So 4 1, it is satisfying, 4 1 is satisfying. And next 5, if I am substituting x value as 5, I have to get y value as 0. So 5 minus 5 plus 5, so I am getting the correct only, 5 minus 5 is 0, so it is correct. Next, after this one, if I draw the line, then I can draw the line like this. So I can easily say this is not there in the edge point. So because of this Hough transform, I can easily draw the lines, and I can easily find out which points will be there in the edges and which are not there in the edge, which are not the edge points. So this is the process that we follow in the Hough transforms. And what is the limitations of this Hough transform is, a large amount of research also has been done on ways to improve the Hough transform because of its limitations. Hough transform method requires a lot of computation power, because just now we have seen it has to do more of this because it is easy to join these lines in case of human can easily draw the lines after finding out the edge points, but it is very difficult for the machine. So that's why it has to follow this process. First those points should be converted into lines, and after this one you have to find out the intersect points, and later we have to find out this line equation. Once the line equation is found out, we will try to find out whether which are the points are there in the edge form formation and which are not there. We will neglect those edges. So it is very requires a lot of computation. It also requires more space, and its output is always not correct. So it may be some that's why it has some limitations. Yeah, that's it, man. These are related to this edge linking process. So we are having these two edge linking algorithms. One is your uh, local edge processing, in which we are having a simple criteria. In case of this one, we will try to satisfy, if those points are satisfying these two conditions, then I can say it is those points will be linked. Otherwise I won't consider those as edge points. In case of this Hough transform, we have to follow that process. Okay, ma'am. Thank you, ma'am.